I'll just remind you that as we're moving through this vodcast of section 3.2, to be continuing to add to your notes from your NOBO that was provided in class. Before we get started, let's do a quick review of section 3.1, which we talked about ionic compounds and we talked about covalent compounds. Now there were two things that we mentioned about ionic and covalent compounds. The first being what bonds together in them. So if you remember, in an ionic compound, these were the bond that was formed between a metal and a non-metal. And in a covalent compound, we were talking about the bonding that occurs between two metals. Now, the difference in this bonding is that ionic compounds, they have a transfer of electrons. Whereas, when you're looking at covalent compounds, this is where they share their electrons. So they share fair rather than giving them up. So in this section, we're going to talk about naming and writing of basic ionic compounds. So let's first start off with the naming of ionic compounds. And so here's the naming. These ionic compounds are composed of positive ions. And if you remember, positive ions, when you look on the periodic table, are all those ions that are metals. And the negative ions are the ions that are all nonmetals. So just as we just reviewed, this is a bond that occurs between metals and nonmetals. So in order to name an ionic compound, we are first looking at naming the positive ion first always, and then at the last part of the name, we're going to put on the negative ion, and we're going to change its ending to add IDE. So let's look at a few examples. So here's our first example, MgO. So if we're looking at MgO, we would see that there is two capitals. So those are each the beginning of a new atom that are on the periodic table. So the rules say that we may name the positive ion first. So looking in your periodic table, yes, you should have a periodic table out for this lesson. You can see that our first atom there is magnesium. Our second atom, if looking on the periodic table, O, is oxygen. And so in naming this ionic compound, what we're going to do is drop the ending, and there's the ending that we're going to drop in oxygen. And so this compound is called magnesium, and dropping that ending, oxide. So some of the nonmetal ions on the periodic table, it's quite obvious the part that you're ending and adding IDE to. For example, fluorine becomes fluoride. Chlorine becomes chloride. And here you can see bromine becomes bromide, and iodine becomes iodide. Now, not all of them have that nice INE ending, and so some of them just become a little bit more, you have to become a little bit more comfortable with them to figure out what their ending is. This is one we just had gone through. Oxygen becomes oxide, and this sulfur here becomes sulfide. Selenium, selenide. And nitrogen becomes nitride, and phosphorus becomes phosphide, and carbon becomes carbide. So there are the endings that you need to become familiar with in order to name ionic compounds. So here's another example, Ca3N2. Now we're not going to worry about the 3 and 2 quite yet because you're going to understand why those exist in a little bit. But let's look at this first positive ion. So Ca, when you look up on the periodic table, is calcium, N is nitrogen, and when we change the ending of nitrogen, this ionic compound is called calcium nitride. So now that we've gone through that, pause this video for a second and see if you can come up with the names for NaCl and Li3N. And hopefully you will be able to figure those out without too much difficulty, that the first one is called sodium chloride and the second one is called lithium nitride. So here are the formulas for the 3 ionic compounds that we just spent some time naming. Now I'm wondering if between each of these compounds that you can see a pattern, something that exists within each of them that is going to help you recognize when you're dealing with an ionic compound. Can you see the pattern? each one is always going to have two capitals. Now, I briefly already mentioned this, but here are the capitals. This way we know that these are atoms that are coming from the periodic table. Now, there's going to be a different list later that we're going to spend a little bit more time on called polyatomic ions. So I just wanted to draw your attention to this now so that later when this comes up, you can be looking for the amount of capitals listed within a compound. So we just finished talking about how you name an ionic compound. Now we're going to look at how you write the chemical formula for an ionic compound. So here are the steps. The first one says, in an ionic compound, the positive charges balance with the negative charges. Okay, so here's the first way. I often draw this as a teeter-totter, or kind of a scale where we have something balancing the middle. What I want to show you here is that the metals have to be balanced out with the non-metals. And when I say that balance, it means their charges have to be balanced. So let's just take an example. Let's take sodium, which we know is a metal. That's the one that we experimented with in class when we went outside and watched it blow up when reacted with water. And let's take sulfur, which, looking at the periodic table, has an ionic charge of -2. Now, right now, if I would look at this, I would say, okay, I have one positive on this side, and I have two negatives on this side. And I would ask myself, is this balanced? And if my answer is no, then I'm going to need to balance that. And in this case, it is no. So what I do in order to balance this is that I would add on more ions until the charges were balanced. So in this case, I'm going to add on another sodium ion. And so here's my extra sodium ion. And now, as you can see, I have two positive charges on the left side, and I still have my two negative charges on the right side. So I would say yes, that this is now balanced. Here is another way to do this. You can draw yourself a table like the one I've drawn here. I put my positives in one column, my negatives in another, and then I begin to write in what I have. So we started off with sodium and sulfur. Now I can see that this right now is a charge of +1, and this is a charge of -1. I want these two columns, when added together, to equal 0, and right now they do not. So if I'm going to erase those, and I'm going to come back and I'm going to say, okay, in order to balance this, I'm going to need to add on another sodium. Now my total in this column is +2. And my total from the one sulfur is -2. Now I would say, adding those two together, it does equal 0. So now that is balanced. So now the question is, what do we do with that information now that you've balanced the charges on the metals and the charges on the non-metals? So this is where these subscripts come in. Now a subscript just means a small number that's listed below. So this is where I go back to the amount of atoms I wrote down when trying to actually balance the charges on those ions. So here you can see I have one sodium here and I have another sodium here. So this means in order to balance it, the amount of sodiums I had was 2. And there's that first subscript that goes in there. Now my next one, my non-metal ion, or my negative ion, gets listed next. And I only had that one sulfur ion when balancing the charges. So I could put a 1 there, but as I've said before, 1s in chemistry do get quite messy, so we're not going to include that one. Now the last step that we do is to always make sure that the ratio is always written in reduced form. Now I'm going to come back to that one a little bit later, but just let you know that that is a part of the step also. Okay, let's walk through a few examples. So we're looking at calcium fluoride, and when I looked these up on the periodic table, I know that calcium has an ionic charge of +2, and fluorine has a charge of -1. So my second step is to ask myself, do the charges equal 0 or are they balanced? If your answer is no, then you need to either go through your teeter-totter method or your table method in order to balance them out. So let's start by knowing that we put the positive ions on this side, the negative ions on this side. So I see calcium has a charge of +2, fluorine has a charge of -1. And looking at this right now, these are not balanced. On my teeter-totter, I know that this side would be much heavier. So in order to balance this, I need to add on another fluorine ion, which now there's a charge of -2. Now my teeter-totter would be balanced. Looking at your table method, here's your positive and negative columns. I have calcium with a charge of +2 and fluorine with a charge of -1. +2 and -1 are not currently balanced, so that does not work, and therefore I would have to add on another fluorine ion. Now my total is +2 in the positive column. My total in the negative column is -2. When adding those two together, yes, that would equal 0. So we're not done here. We still have to write the chemical formula. So the formula then would be including those subscripts. So I write both symbols down. There's the Ca and the F. And I can see here that I only had 1 calcium and I had 2 fluorine ions for every 1 calcium that was there. And so your chemical formula is CaF2. Let's try another example, one that's a little bit trickier. Magnesium phosphide. First step, look it up on the periodic table, find the symbols, which magnesium has a charge of +2 and phosphorus has a charge of -3. So my next question is, do the charges balance? Is +2 equivalent to -3 if we're looking at the teeter-totter? If your answer is no, then you need to use your teeter-totter scale or your table in order to balance the charges. So again, I will show you both methods and you can be determining on which method you like best. So here I have magnesium, its charge is +2, and I have phosphorus, my negative ion with charge of -3. I can see +2 and -3 are not balanced. So I'm going to add another magnesium ion. Now I have a total of +4 on this side and a -3 on the phosphorus side. So I'm going to add another phosphorus, charge of -3. Now I have a total of -6. So therefore I can see that if I add on another magnesium, those 2 charges will be added up to be +6. Now I would say this is balanced. Here is the table method. If I'm looking at the table of positive ions to negative ions, and there's where it needs to equal 0, my positive ions I would write in my magnesium, +2, phosphorus, -3. I can see that they do not equal 0, so magnesium, add another one, add one more, and now I have a total of +6. If I add one more phosphorus, I'm at a total now of -6. Now I could say that that does equal 0 when added together. And so my chemical formula, I write both symbols down, and then I figure out how many ions I wrote down of each. So magnesium, there was 1, there was 2, and there was 3 magnesium. That's my subscript that goes in there. Here I can see phosphorus 1, phosphorus 2, so I have 2 phosphorus molecules, and that would be magnesium phosphide. Now you don't have to always label all these steps, but I'm trying to break it down in step by step for you so that you can see the end result. So lithium bromide, I'd like you to give that one a try on your own and then come back and see if you got the right solution. So hopefully you came up with the answer by figuring out that lithium's charge is +1, bromine's charge is -1, so they are already balanced. So your formula would be LiBr, and we're not going to include any of those ones because in chemistry it would get really messy if we always included ones. But to prove it to you, here's my teeter-totter. Lithium's positive charge on the left side, bromine's negative charge on the right side, which means that on the teeter-totter, this is nice and happy just being flat. That brings us to the end of our vodcast for basic ionic compounds, naming and writing of ionic compounds. There'll be another one like this, talking about multivalent metals. See you next time.